my apps benefited from other people's software, which made my programs many times better than anything I could write on my own. And this is what made me see the power of open source and really understand the value of open source at a young age. So, why would you want to learn Linux? Well, Linux gives you a better understanding of what's happening under the hood of your computer system. And it makes you a more productive programmer and a more hands-on computer user. You can't really know what is going on behind closed source applications running on your computer because you can't see or audit the source code. So a lot of times you could be running potentially malicious or nefarious apps or code and you are unaware of it. So why would you want to learn about the history of Linux? Well, learning about the history of Linux gives you a good appreciation for the people and the ideas behind Linux and the open source movement. And understanding the ideas behind Linux will help you understand why Linux is so powerful and is such a robust and flexible operating system today. So, how many here know the history of Linux, or have some understanding of the history of Linux? Some people? Okay. How many understand the history of Unix? Some others? Okay. All right. Well, to understand the history of Linux, it's a good idea to start with the history of Unix, because Linux was inspired by Unix. So, Unix was an operating system created back in 1969 by two guys at the Bell Laboratory Research Division of AT&T. It was created by Dennis Ritchie, who is also the creator of the C programming language, and Ken Thompson. And they set out to create an operating system that was easy to use and basically easy to use. The operating systems at the time were complex, they were not very user-friendly, and these guys wanted to reverse the trend. So I'm going to play you a short clip from AT&T archives where these two explain their motives behind the Unix operating system.
Back in 1969, a couple of computer scientists here at Bell Labs started to develop some programs they needed for their own use. What Ken Thompson and Dennis Ritchie started developing then has evolved into the Unix operating system, which by now is widely used around the world.
We are trying to make computing as simple as possible. In the late 1960s, Dennis Ritchie and I realized that the then current operating systems were much too complex. We attempted to reverse this trend by building a small, simple operating system on a mini computer.
Well, what we wanted to preserve was not just a good programming environment in which to do programming, but a system around which a community could form, fellowship. We knew from experience that the essence of communal computing, as supplied by remote access time-sharing systems, is not just to type programs into a terminal instead of a key punch, but to encourage close communication.
The Unix system started out as a two-man effort, and by now it's used all over Bell Labs. We have close to 20,000 computer terminals in this company, roughly one per employee, and most of them are used for communicating with Unix systems. One of the main reasons the Unix system is popular around here is because it provides graceful facilities for decomposing complex computing tasks into simple subtasks.
The Unix operating system is basically made up of three parts. The kernel, or operating system proper, is the part that manages the control of the machine and supervises scheduling of the various user programs. The shell, or which is the name we give to the command interpreter, looks after the communication between the user and the system itself. And the third part, which is actually the largest, is the various utility programs which perform specific tasks like editing a file or sorting a bunch of numbers or making a plot. In other words, all the other programs that are not provided directly as part of the operating system kernel.
So what Unix pioneered was the philosophy and the implementation of a simple, easy-to-use operating system that consisted of a kernel, which was the core of the operating system, a shell, which was the command interpreter, where the user would type commands and interact with the system, and utilities or applications. So Unix becomes very popular in the 70s and 80s. But the source code for Unix is closed off. It's a proprietary system. So in the 80s, there was a man named Richard Stallman, who's shown here. He's a very eccentric man. And he wanted to create a Unix-like operating system that was free and open source, where people could change the code and use the code as they saw pleased, with some limitations. And he sets out to start a project called the Canoe Project, which is GNU, which stands for GNU is not Unix. And he does this in 1984. And he's on a mission to rewrite Unix software completely from scratch to be open source. And he is seen as the philosopher behind the open source movement and free software. So he begins the GNU project in 1984, and he also establishes the Free Software Foundation in 1985, which helps facilitate the development of the GNU tools. He also creates the GPL license, which is the general public license that is used to help protect free software from being misused and to help free software continue to be free. So now I will play a clip about Richard Stallman and the GNU project. This clip is from the documentary Revolution OS, which is a great documentary that you can find on the internet. And I'm just playing a 10-minute clip.
In the late 70s and early 1980s, Richard Stallman was doing artificial intelligence research and coding at the MIT Artificial Intelligence Lab. Richard had a number of negative experiences during that period which soured him on the whole idea of commercial software.
Such as?
Some code that he wanted to work on and wanted to fix was locked up, and he couldn't get the company that owned the code to let him fix it, even though it would have been to their advantage to do so.
And that put me into a moral dilemma, you see, because to get one of the modern computers of the day, which was the early 80s, you would have to get a proprietary operating system. The developers of those systems didn't share with other people. Instead, they tried to control the users, dominate the users, restrict them, saying, if to get this system, you have to sign a promise you won't share with anybody else. And to me, that was essentially a promise to be a bad person, to betray the rest of the world, cut myself off from society, from the cooperating community. And I had already experienced what happened when other people did that to us when they refused to share with us because they had signed these contracts. And it hurt the whole lab. It kept us from doing useful things before. So I just wasn't going to do that. I felt this is wrong. I am not going to live this way.
And from experiences like this, he developed a profound hostility to the idea of intellectual property in software. He eventually acted this out by founding the Free Software Foundation.
So I looked for another alternative, and I realized I was an operating system developer. If I were to develop another operating system, and then as the author, encourage everyone to share it, say, everyone, you come and get it, use this, form a new community, not only could I give myself a way to keep using computers without betraying other people, but I'd give it to everybody else too. everybody would have a way out of that moral dilemma. And so I realized this was what I had to do with my life. I actually began the project in January of 1984. That's when I resigned from my job at MIT to start developing the GNU operating system. Now I should explain that the name GNU is a hack because it's a recursive acronym. It stands for GNU's not Unix. You see, so the G in GNU stands for GNU. And what the name means is I was developing a system that was like the Unix operating system, but was not the Unix operating system. This was a different system. We would have to write it completely from scratch because Unix was proprietary. We were forbidden to share Unix. We couldn't use Unix. It was useless for a community. So we had to write a replacement for it.
Throughout the 1980s, as Richard Stallman was building the Canoe Project, computer scientists from the University of California at Berkeley were developing their own free operating system. Known as Berkeley Unix, or BSD, it was based upon the Unix kernel which had been licensed from AT&T. However, due to legal problems with AT&T and fragmentation of the source code, hackers and other non-institutional users were slow to adopt it.
Well, Unix consisted of a large number of separate programs that communicated with each other. So we just had to replace these programs one by one. So what I started doing was writing a replacement for one program, and then another, and then another, and then people started joining me because I published an announcement inviting other people to join me to help write these programs. And by around 1991, we had replaced practically all of them.
What were some of the programs that you...
Well, we had to have a complete system, you need to have a kernel, which is the program that allocates resources to all the other programs. You need a compiler, which translates a program from readable source code that programmers can understand into numbers, mysterious numbers that the computer can actually run. You need other programs that go with the compiler to help do this job. You need a debugger, you need a text editor, you need text formatter, you need mailers, you need lots and lots of things. There are hundreds of programs in a Unix-like operating system.
I saw Stallman's announcement. Actually, I met him in February of 1987. He came to give a 5-day tutorial on Emacs at our company. And during the day, he would explain new ways to think about Emacs and ways to extend and enhance it and to use the Emacs source code for better or worse. But in the evening, he was busily working on this compiler, and he had not yet released it to the public, so he was being a little bit careful about who got to see the source code. But I was very eager, and when he first announced it in June, I downloaded it immediately. I played with it. I got some pointers from him, and when I sent the source code back to him, he was very actually amazed at how quickly I was able to ramp up on his technology.
Whenever we worked on something at Stanford or in the university, we would get, mostly at the time we were working off of machines from Digital Equipment or Sun, mostly Sun. Whenever we would get a Sun machine, the first thing we would do is we would spend literally days downloading GNU free software from the internet, building it and installing it on that Sun machine.
The crucial thing about GNU is that it's free software. Now, free software refers not to price, but to freedom. So think of free speech, not free beer. The freedoms that I'm talking about are the freedoms to make changes if you want to, or hire somebody else to make changes for you if you're using the software for your business, to redistribute copies, to share with other people, and to make improvements and publish them so other people can get the benefit of them too. And those are the freedoms that distinguish free software from non-free software. These are the freedoms that enable people to form a community. If you don't have all these freedoms, you're being divided and dominated by somebody.
My first experience contributing to free software came in late 1989, early 1990. I was working as a graduate student at Stanford University on computer-aided design tools. One of the pieces I needed was a tool called a parser generator. Well, the Free Software Foundation under Richard Stallman had created a great tool called Bison. I needed a tool that worked with C++. Bison worked with C. I modified Bison to create something called Bison++. And it's a tremendous feeling of empowerment to be able to take a piece of software that was available and create what you needed in a very short piece of time by modifying it. I put it back on the internet, and I was amazed at the number of people that picked it up and started using it. In fact, I remember going to job interviews. I, at various times, considered just going out and getting a job, and I had gone to a job interview, and I was talking with one of the people, and I started asking them about what tools they used, and they said, gee, we use Bison++. And I said, oh, I'm the author of Bison++.
Free software generally does have a copyright, it does have an owner, and it has a license. It is not public domain.
If we put the software in the public domain, somebody else would be able to make a little bit of changes and turn that into a proprietary software package, which means that the users would be running our software, but they wouldn't have freedom to cooperate and share. To prevent that, we use a technique called copyleft. The idea of copyleft is that it's copyright flipped over. And what we do is we say, this software is copyrighted, and we, the authors, give you permission to redistribute copies. We give you permission to change it. We give you permission to add to it. But when you redistribute it, it has to be under these terms, no more and no less. So that whoever gets it from you also gets the freedom to cooperate with other people, if he wants to. And then, in this way, everywhere the software goes, the freedom goes too. And it becomes an inalienable right to cooperate with other people and form a community.
And so what is that, the license? What is that?
Well, copyleft being a general idea, in order to use it, you have to have a specific example. And the specific example we use for most GNU software packages is the GNU General Public License, particular document in legalese which accomplishes this job. A lot of other people use that same license. For example, Linus Torvalds uses that license for Linux as well.
Well, the license I use is the GNU General Public License. That's the one that Richard Stallman wrote, and I think it's a really astounding contribution. It's one of the few software licenses that was written from the standpoint of the community rather than from the standpoint of protecting a company or, as is the case with the MIT and the BSD license, performing the goals of a government grant program. And the GPL is really unique in that it's not just a license, it's a whole philosophy that I think motivated the open source definition. I don't hide that a lot of what I do came from Stallman.
So Richard Stallman creates the GNU software suite, and it gains in popularity throughout the 80s. But the project is still missing a kernel, and they need the kernel to complete the GNU operating system. So they have all the tools of a Unix-like operating system, but they're missing one crucial aspect of it. They have text editors and compilers and debuggers, but they're missing the heart or the core of the operating system. And so enter Linus Torvalds, who was a student at Helsinki University in Finland, and he was just developing an operating system kernel for fun. He had no intentions of the kernel becoming part of the GNU system, which it later does become part of the GNU system. And he famously posts on the internet about how he's doing a small project and that it's not going to